Okay, so last video, I'm gonna wrap this thing up. All right, hopefully we'll see some connections here. These were some rules from Algebra 2, and this is actually how I keep my sine and cosine identities straight. All right, I don't try to memorize all the different possible ways, like all these identities. All right, I don't try to memorize all these because it's too much. I just think about sine and cosine, how they are translations of each other. All right, those are to me it's easier. It may not be easier to you, but you should still try to see the connection. All right. So we've got the graphs of sine and cosine here. Obviously, they are related to each other. My red one's sine, and sine, as you can see, like if I'm just going from this purple hump to this red hump here, it's to the right. So the red one is to the right of the purple one. Sine is to the right of cosine. Now, the rules from Algebra 2 went something like this. If you subtract on the inside of the parentheses, it's going to move your function to the right. If you add on the inside of the parentheses, it's going to move your function to the left. I'll get to this one later, maybe. But these two right here, this is how I keep sine and cosine straight. All right, how I keep them straight. They're wavy functions. They're obviously not straight. It was a joke. All right. So sine and cosine, here's the graphs. You can get from sine to cosine by scooting this function. If you were able to scoot it to the left, you would get cosine. All right. That's that's a true statement. You can get from the red one to the purple one by scooting it to the left, and then everything would line up. Like this bottom hump, if you scoot it to the left, it's going to line up with that purple hump down there. All right. Let's look at some of these. I'm going to look at these identities here. So these were two of my identities. These are actually the main ones. All right. This is literally just a translation of sine and cosine. So in words, what this statement means, what this identity means, is that if you take the sine function and take it to the left pi over 2 units, you're going to land on cosine. All right. So take your sine function, your red one, and if you see where pi over 2 is right here, that's my x value. If I take this and shift it to the left pi over 2 units, it's going to line up with that purple one. All right. So I take this and add pi over 2 units, I'm right on top of the purple one. The other way of saying it, instead of saying move the red one to the left, you could also say take your cosine function and move it to the right, and you're going to land on sine. All right. So this one, they're saying the exact same thing. Cosine shifted to the right pi over 2 units. All right, I guess I should say equals cosine. This one would equal sine. All right, it's a relationship that the two curves have with each other. So if I were to take this purple one and shift it to the right, I would land on top of the red one. All right, so this would be minus pi over 2. And yep, the purple one is now landing on top of the red one. All right, if I wanted to, I guess if I wanted to kind of do it slowly. So here's 0. This is if I don't have any change here. But if I want to shift it to the right pi over 2 units, I'm going to drag this until my a value here, until that's equal to pi over 2, which pi over 2 is about 1.6, 1.7, somewhere in there. Okay, so you can get from cosine to sine by shifting it to the right. You can get from sine to cosine by shifting it to the left. That's literally what these two statements mean. And they're saying the same thing, just one saying it backwards from the other. Instead of saying the pencil is to the right of the marker, the other one saying the marker is to the left of the pencil. That's what's happening there. Okay. All right. These two are a little bit different, I guess, because of the reflection business. So what this says is you're going to take the sine function and you're going to go to the right. So instead of going to the left and landing on exactly cosine, this says take your sine function and move it to the right, and that's going to equal the opposite of cosine. Let me back this thing out here. So if I take my sine function and move it to the right, which is minus pi over 2, all right? So this little starting point was right here, but now I've moved it to the right, and now you can tell from the difference in the two humps here, they're just off by a negative, right? So if I looked at negative cosine instead, they would be right on top of each other. So what I'm doing is I'm taking the graphs. I'm taking the graph of the sine function here, and I am moving it to the right a bit, and then I'm flipping it. That's what's happening there. All right. So the other way to say it, instead of moving sine to the right and then flipping it, is to say I can move cosine to the left and then flip that one. Okay. So if I had my cosine function here, let me take off this slider thing. So if I wanted to get from the purple one to the red one, but I wanted to move cosine to the left, right? So now I have moved it to the left. I would have to reflect it across that x-axis, and that's where that negative comes from right here. Flips across the x-axis. So I'm moving cosine to the left, and that's equal to the opposite of sine of x. So if I take this and I add a negative there, they're going to be right on top of each other now. Or I could have taken this one and added a negative to it, and it would be the same as my original sine of x. So all these are graphical, I guess they're algebraic representations of things that are true graphically. All right, but they're just saying them different ways over and over. So you got your regular sine and cosine. There's lots of ways of getting from one to the other. All right, you could take sine and you can move it. You can move it to the left, and that would give you cosine. You could take cosine and move it to the right. Remember, cosine is the purple one, and that would give you sine. You could take the sine function, instead of moving it to the left, you could move it to the right, but then you would have to flip the function, and then they would line up perfectly on top of each other. All right. So lots of ways to express these. Hopefully you got something out of all these. I really hope you got something out of all these. Anyway, that's sine and cosine graphs. Later on, we will, these things actually do get used a lot. But later on, we'll look at secant and tangent and all those too. Okay.